Hello everyone. In this lecture, I am going to discuss about distributed system and the global state of a distributed system. Now we will see the introduction to distributed system. Distributed system is a collection of autonomous processors communicating over a communication network which is going to solve a complex task. The task cannot be solved by an individual machine. The characteristics of distributed systems are there is no common physical clock exists in the distributed system, and there is no shared memory between the processors. The processors can be in a different geographical region. The processors are autonomous and are of different types. This figure shows the system model of a distributed system. Here, the systems are connected through a communication network, and each system has its own processor and memory. There is no shared memory between the processors. Now we will see the global state of a distributed system. The global state of a distributed system is found by the collection of the local states of all the systems present in a distributed system. The local states of a system will be determined by the state of a process and the state of a channel exist in that. The state of a process is defined by the contents of processor registers, stacks, local memory, and other things which depends upon that local context of the distributed application. The state of a channel is given by the set of messages in transit in the channel. The occurrence of events changes the states of respective processes and channels. There are three types of events in a particular system: internal event, send event, and receive event. An internal event changes the state of the process at which it occurs. A send event changes the state of the process that sends the message and the state of the channel on which the message is sent. A receive event changes the state of the process that receives the message and the state of the channel on which the message is received. So, an internal event affects only the particular process. Send and receive event affects both the state of the process as well as the channel. This is the notations for representing the local state of a distributed system. LSI power x denotes the state of process Pi after the occurrence of event EI power x and before the event EI power x plus 1. LSI power 0 denotes the initial state of process Pi. LSI power x is a result of the execution of all the events executed by process Pi till EI power x. Let send of m which is less than or equal to LSI x denote the fact that there exists y such that 1 less than or equal to y less than or equal to x. Which means that EI power y equal to send of m. That is, the send of m will be recorded within the local state of the x. And let or receive of m which does not belongs to less than or equal to LSI power x denote the fact that for all y 1 less than or equal to y less than or equal to x, ei power y does not belongs to receive of m. That is, the receive of m does not happen within the LSI of x. Channel state. The state of a channel depends upon the states of the processes it connects. Let Sci power x comma y denote the state of a channel Cij. That is, the channel exists between the process Pi and Pj. The state of the channel is defined as Sci power x comma y equal to Mij. That is, the message sent by the process Pi and does not receive by the process Pj. Thus, the channel state Sci power x comma y denotes all messages that Pi sent up to event Ei power x and which the process Pj had not received until event Ej power y. Finally, how to find the global state of a distributed system. The global state of a distributed system is a collection of all the local states of the processes and the channels. This is denoted by GS equal to union of the local states present in it and the union of all the state of the channels. For a global state to be meaningful, the states of all the components of the distributed system must be recorded at the same instant. This will be possible if the local clocks or processes were perfectly synchronized or if there were a global system clock that can be instantaneously read by the processes.